In today's tutorial on solving exam riddles in organic chemistry, we have a look at a frequently occurring problem, the synthesis of carboxylic acid amides starting from a carboxylic acid and an amine. Here we have tertiary-butylamine and benzoic acid as examples. Formally, it's just the elimination of one equivalent of water. However, this does not work since the simple acid-base reaction, the protonation of that amino group, will win. Very fast reaction, of course, forming this ammonium carboxylate. If you take this salt and heat it up above 200 degrees, then finally water will be eliminated. However, this is not the normal synthesis of it, since this method would not work with more complicated structures with lots of possibilities of competing reactions at higher temperatures. So, one could think about transforming the carboxylic acid to a carboxylic acid chloride. Of course, this works, but these chlorides are normally also not compatible with other sensitive functional groups. A method of choice very often is using a carbodiimide as a reagent. And now we should have a look at the mechanistic scheme that evolves when you start with a carbodiimide and a carboxylic acid. We should develop the mechanistic scheme, and this is indeed rather easy, although overall it looks complicated, but it isn't. Well, let's have a look. Again, first step, we have a carboxylic acid, we have basic imino groups. What will happen? A proton transfer. Acid-base reaction, this is protonated, and of course it's protonated at those 3 electron pairs. Doesn't matter which one in this case, here is the protonation. So then the central carbon becomes an even stronger electrophile. The carboxylate is the nucleophile. It's just as the next step the formation of the oxygen-carbon bond. And now we are already here at this intermediate. So now the tertiary-butylamine comes into play. It is a nucleophile with a 3 electron pair. Where do we have electrophilic centers? Well, the strongest electrophilic center is this carbonyl carbon of that ester functionality. So adding in delivers as a reactive intermediate this ammonium group and this negative charged oxygen. Now we have again a basic imine functionality in close proximity to those acidic hydrogen. A proton transfer takes place. Now we have this iminium cation, and again here the high electron density. Well, in a concerted process, from that single bond, a double bond will be formed. At the same time, this single bond is broken. From this single bond, we form a double bond, and that cationic nitrogen is neutralized. If we follow this scheme, we will see that we end up with this structure, and it's the structure of our target molecule, that carboxylic acid amide. And the second product is this one. Well, what is this? This is, well, a urea derivative, neutral compound, very stable, usually crystallizes out of the solution. Thanks for listening.